Very good afternoon, all of you. I am audible. I am audible na beta? Okay. Now, if I am audible, then we can go for last topic. Yesterday we are discussing, and we can I'm just recollecting the previous class information. We have discussed this one. That is the electric flux. This was the topic we are discussing. Okay, last class. The electric flux, I told you what is the meaning of that flux. So flux we have written phi is equal to integration of E dot ds. Okay, E is the electric field, ds is the area. So we can put it, electric field we call Newton per Coulomb, and area is a meter square. So you can directly say this is nothing else. If I want to write the unit of this part, the unit would be beta. You can write it very simply. Its unit would be Newton per Coulomb. This is the SI unit of we can say the electric field, and this area is nothing else meter square. You can say this is the SI unit of flux. So flux SI unit is the Newton per Coulomb meter square, or you can say Newton meter square per Coulomb. That's the very basic thing that we can write it. And based upon this, we have already told you that this is a scalar quantity. And based upon this, we have solved few questions, beta. Very good evening. Okay, King. Very good. Thank you, beta. Okay. So this was the very basic thing that we are discussing. After that, what we have discussed, for a closed body or in an open body, how we are seeing the entering flux or exiting flux or total flux. So I told you the entering flux is nothing as negative, and exiting flux we take is positive, and accordingly we can write the total flux also. So based upon this, we have discussed the few concepts. The very first concept related to this Q problem, and here I have taken the electric field constant value. Note variable, it is a constant value, 3i cap plus 2i cap plus 3j cap, or 3i cap minus 5j cap plus 11k cap, but constant electric field we have taken, and we solved this question. After that, we have taken this electric field, now variable form, not a constant form, it is a variable form we have taken that depends on x or it depends on y. So accordingly, we have discussed the two questions here, that the electric field is equal to 2xq, or electric field is equal to minus xi cap plus 2y square j cap, and accordingly we have discussed the flux entering and flux exiting in the this questions. Okay, now this was the question I have given as a homework. Have you tried this question, beta? King and other person in the chat, in the class, beta, please reply. This question have you tried? If you tried, tell me your answer. What the answer is coming, beta? What is the answer is coming? Okay, no one has tried, I think. So now we have to discuss this thing again. I'm telling you, there are two fields there. This is the field 1, it's the E1, and this field is E2. Now this is a very, very important thing that you have to learn it first. If you are learning it, then only you can understand it. Okay, so I'm going to explain the very basic thing. Please take care. I'm giving you one example. You will take, suppose this is the one bowl. This is a ball. This is a ball is there, ball. In ball, this you are seeing, okay, this is a curved surface. Okay, this is a cylinder type, or you can say frustum type thing is there. So this is a frustum type or bucket type of shape is it is. Okay, for simplicity, I am just taking it. This is a shape, curved shape is there. Okay, now, and this shape is a circular shape. It is a circle shape. Okay, it is dirty. Don't go into the dirty part of this. Okay, just try to understand the concept. Very good evening, Chandana beta. Now please understand it. What I'm saying, this is the one circle. This is one circle. Try to understand it. This is circle, and this is the curved part. It is a curved part. Okay, please understand it. Now I am taking this edge like this. Now try to understand this is circle, and I am assuming suppose its radius is r. So what is the area of this circle? Can you tell me? Can anyone tell what is the area of this circle, beta? If radius is r, what is the circle radius area? That is equal to pi r square. What is the area? Pi r square. This is the area of this circle. So area of this circle is nothing else pi r square. We can put it. Now pi r square area of this circle means this disk. Okay, this disk. This area is a pi r square. If I say there is one electric field is there, and electric field is coming perpendicular to this surface like this. Electric field is coming perpendicular. Okay, very good, beta king. So this is the electric field is coming perpendicular to this area. Area is how much? Pi r square. Electric field I am assuming E. So if I ask you what is the actually flux associated with this circle, so what you will say is the area we know pi r square, field is perpendicular, so field into area, that means E into pi r square. This is the flux associated with this disk, or we can say circle. Clear or not clear, beta? Please tell. This is clear to everyone? Okay, this flux associated with this circle would be pi r square into E. Clear? So this is the very basic thing I am telling you. Now, okay, Chandana, very good, beta. So this is a pi r square into E. We can multiply and we can get the flux associated with this circle. Got it, beta? King, Chandana, this is clear, beta? Now the question is that how much flux associated with this curved part? How much flux is associated with this curved part? How to calculate? Very difficult, because this is curved surface. It is a curved surface. If it is curved surface, how to calculate the field? Field is there E, okay, no problem. But area to get little difficult. And angle between area and field is also difficult, because every point it is changing. Then it is difficult to solve it. So how to solve this question? Try to understand basic. Try to understand basic. So there are two ways to understand the same thing. I am telling you a very simple case. Whatever field is entering from this side, whatever field is entering from this side, the same field is coming out from this side. Same field is coming out. That means from this side, whatever they are entering, the same is coming out. So this side field is E, this side also field E. This side flux is nothing else what, beta? This side flux is nothing else what we call it, pi r square into E. This side flux is nothing else, pi r square into E. So what is coming out? Same, pi r square into E. Coming out we call it positive, entering we call it negative. That is your choice. That's the sign convention. But this is part, from this side the flux entering is pi r square into E. Then from this side, what are the flux is coming out? Pi r square into E. Correct or not correct? This thing is clear to everyone, yes or no? Chandana, King, and other questions, please reply. If this basic concept is clear or not clear? Clear, beta? Now I will explain the same thing in different manner. Clear? Very good, beta. Now listen carefully what I am going to tell you here. The very first thing, very first thing, listen carefully. This same concept we can explain in different manner. That we call it projected area. That concept we call it projected area. In the physics, it is used in many different places. Many different places we call it. I am telling you again this diagram. I am trying to draw it here. Please focus. Suppose this is the one circle was there, and this is the shape like this. Suppose this was a shape is there. No problem. This was a little bit frustum type shape is there. So I draw, okay, and this radius is equal to r. Now, if I ask you, there are two things. What are the two things? You can say very simple. Sir, this is the surface one. This is surface 1, I am taking it. And this whole curved part I am saying this is surface 2. Clear or not clear? If I ask you what is the surface 1, what is the surface 1 area? So you will say surface 1 area A1 is equal to pi r square. Very basic. It is the area pi r square. Very, very simple thing I am telling you. Pi r square is the area. Now question is that this surface 2 area, but it is a very difficult to find. This is what shape we don't know. So we are not interested exact area. We are interested in projected area. What we are interested beta? Projected area. So when we are calling it projected area, what is the meaning of projected area? Please understand it. So if you are making this diagram, and if you say here, I am drawing it again, the same diagram, please focus. Suppose this is the shape is there like this. Okay, this is the shape. I am trying to draw it again, and this is the shape is there. And this radius again, I am saying this is the radius is r. I am not changing anything. Okay, this is the shape. Now if I say, if I take a torch, okay, this whole system is placed in a dark room on a table. This system type thing is placed on a table like this, and the dark room means there is no light. And if I take a torch, and from that torch perpendicularly I am keeping this torch and I put it on the light, then what is the shadow of this body will be formed? That we call it projected area. What is the shadow of this body is going to form on the table? So I want to see it. So if I put the torch from this side like this, this is a torch. So shadow would be formed this much. This is the shadow because this is the area on the surface. That area also we call it projected area. What we call it? Projected area. Projected area of surface 2. Surface 2. This is the surface 2. So surface 2 projected area is this. And already you know, by the way, this projected area, how much value? This area also equal to pi r square. This area also equal to pi r square. So what you understood? So this is the A1 area. This is your A2 projected area, that is also pi r square. That's why I was able to say that the flux entering from this side is also pi r square into E, and flux exiting from this side also pi r square into E. Okay, entering we call negative, that is the minus pi r square into E. Exiting we take is positive, that means plus pi r square into E. This concept is clear, beta? This much is clear, Chandana, King. Okay, and other person also in the chat box, you can tell it is clear to everyone. Clear or not clear, beta? Please reply. This concept is clear? Okay, now this is clear to you, I am assuming it, and now we have to solve it. So very basic thing, this is the case here, hemisphere. So for hemisphere, I want to write what is the flux entering, what are the flux exiting, we want to solve it. Okay, Chandana, very good, beta. King, reply, it is clear to you? Very good, beta, understood, very good. Now I want to solve this question. This concept is clear to you, that means you can solve a lot of questions now. Please focus. This was the question I have given as a homework last class. So I want to write it here, flux entering. Flux entering, please understand it. And the second part I want to write it, flux exiting. Flux exiting. These are two questions I want to solve it. So when I am writing flux entering, so from which part it is enter? So there are two fields, E1 and E2. Now first I am focusing only E1. So just take the concept that is the E1. So this is a negative already, because entering flux we take negative, and this exiting we take positive. So I am putting the sign first. It is a minus, this is plus. Now come to the first point. E1 area. From E1, if you take it, so this is the area, beta. It is the area. This is the area, this is the field. Area into field, that is equal, area into field is equal to flux entering. So E1 into pi r square. So directly we will say, this is E1 into pi r square is the flux entering from this E1 on. So due to E1, what is flux? E1 into pi r square. Very good. Now understood. Now second, flux exiting I want to write due to E1. So just now I told you this is a curved surface. For this curved surface also, what is the projected area? Again the same projected area pi r square. So you can say it's a pi r square into E1. Again that is the same flux exiting. Same flux exiting. We can write it. This is the projected area of this curved surface, and curved surface multiplied by projected area, that is pi r square, that is the answer of flux exiting. This is due to E1 we have written. This is clear to everyone, beta? Okay, King, Chandana, and other persons also you can reply. It is clear or not clear, beta? E1, this concept due to E1 what we are writing it. Okay. Now the second concept comes to you here. How much is due to E2? What is the flux associated with the E2? So flux due to E2 is coming, if you see from this side, suppose this is the shape, if I assuming this is the shape, and I'm assuming suppose this is a hemisphere. Try to understand, this is a hemisphere. If it is hemisphere, now try to understand it. This is a curve, but this is only when you put the light from this side, to the shadow would be formed in the half circle. Shadow would be formed only half circle. So this radius is r, and half circle means what is the area? Pi r square by 2. What is that? Pi r square by 2. So you can say is that this area, projected area would be this much only. This would be the projected area. This is the pi r square into 2. Pi area would be projected area. Projected area is equal to pi r square by 2. And just multiply, you can say that this is a E2 into pi r square by 2. This is the flux entering. This is the flux entering due to E2. This is the flux entering due to E2. And similarly, exiting also same, you will write it just positive sign, that is also E2 into pi r square by 2. Just please everyone just tell me if this is clear, this concept is clear to you or not, beta. Please, King, Chandana, reply, beta. This is clear, this concept is clear to everyone. Another person also can reply. It is clear or not clear? Clear, beta. Very good. So this basic question I have given to you. So what is the flux entering? What is the flux exiting? We can write like this. Got it? Now I am giving another example to you. Please try. Please try. Similar question. Very similar question I am giving you. Okay. Question 2. Take it. It is a right circular cone. Right circular cone means this perpendicular is nothing else 90 degree. Okay, if you take this height and radius, it is the 90 degree. I am telling you this radius is r and this height is h. This height is h. Okay, now try to understand it better. I am putting here there are two fields. Two fields. One field is like this. This is E1. This field is E1, and from this side also there the field is there. This side also field is there, that we call it E2. It is E1, this is E2. Now question is there, please write the flux entering and what is the flux exiting. Flux entering and flux exiting, we have to solve it. Got it, beta? Now this is the question for you. Try it. Okay, I am giving a 1 minute time to solve this question. Very good question. Please try. King, beta, very good. And Chandana, if it is clear, very good, beta. Our intention is so that you can learn it. Solve this question. Solve this question, beta. Try this question. Tell me what is the E1, flux due to E1 and E2. What is the entering flux? You have to solve. What is the exiting flux? You have to solve it. King, very good, beta. Very good. Chandana and other persons also please reply. What is your answer? What is the flux entering? What is the flux exiting? Chandana beta. Little mistake there, beta. Chandana, please check it. You have written the E1 into pi r square, correct? Plus second you have written the E2 into r into h by 2. This is not r into h by 2, this is rh. It will come. Okay. King, answer, your answer is correct. Now I am solving this question. Please check it. How to solve? Very good, but if you tried it, definitely it is a good thing. Now listen carefully. When I am writing the flux entering, when I am writing flux entering, that means first put the negative sign. First put the negative sign. Very good. Now, from which part it is entering? You have to check it clearly. So if you are checking it, so due to this part is entering due to E1. This part is entering due to E1. So we will write it first. Is this area is pi r square and this is E1. So directly we can write it. So E1 into pi r square. There is no problem. Similarly, you can write for flux exiting also. Flux exiting, that is equal to plus. Okay. Again, I am saying that this curved surface, the cone curved surface. If you are taking a cone curved surface, suppose if the cone is there, I am taking it. Okay. I will try to make it a little one cone. Just give me 1 minute. Okay. This cone type, sometime we are using in a for Belpuri stall when we go and they are giving us the Belpuri in this. Okay. No beta, Chandana, no problem. Nothing sorry. You are here to learn. King, very good beta. This is the cone type thing. Okay. When you are putting it, if you put the again light from above, so this is a circle will be formed. What is formed? Circle would be formed. So this is a cone is there. You can check this is a circle will be formed. That is the circle part. So you can check here that is equal to E1 into pi r square because projected area is equal to again the same thing pi r square. The projected area of this curved part is again pi r square. You can use it. Now second thing comes to you beta, pi r square you are using it. Second here entering flux. So due to E2, if you see from due to E2, so what will happen? If you see from this side, I am just putting here for you. If this is the one cone is there, beta, right side cone. Okay, try to understand this is the cone is there. So if you are putting this in a 2D, means you are putting it like this, and from here you are putting the light. So it will be formed one triangle. It will be formed one triangle. So what is the length of this? 2r. Because of the diameter. This is 2r. This height is how much? H. This is the what? Base is how much? 2r. And this is how much? H. Now you can find it. Okay. I'm not understanding better TG gamers what you are saying. Okay. So this is a very simple thing. That the triangle would be formed. If you see this is the triangle beta and this is 2r and this height is equal to h. So what is the area? Area is equal to 1 by 2 base into height. What is the base? base is equal to 2r into height is what beta h. So if you say the 2 is cancelled, that is equal to r into h. That is equal to r into h. Beta, I don't know Telugu, so if you are replying in a Telugu, definitely I don't know what you are saying. Another person can tell what he is saying, I don't know. You can translate for me. Chandana Shri, you can translate what he want to say. So this is the entering flux and this is the exiting flux. I'm just telling you, this is the area, R into H you have to use. So entering flux when you are writing, so you know the area, you know the field E2, put it, you will get the answer. This is E2 into pi, not pi, sorry. This is R into H. R into H, you can write it. The second thing is due to exiting flux. Exiting flux when you are writing, this is E2 and again this is a positive, but area would be same, projected area would be same. So you will say E2 into again into R into H, that's the answer. This is the entering flux and exiting flux. Now it is clear beta to everyone, please reply. Chandana, King, TG Gamer beta, another person also, please reply. This is clear to you or not clear beta? If it is clear, we will solve some more problems. I will tell you. Yes, sir. Chandana, very good, beta. Now, come to the next point I want to discuss it, beta. Gayatri, very good. You joined little late, I think. Okay, this is a very simple thing that you have to understand it. King, very good, beta. Now understand this question. Now we are going to solve some more problems. One by one we are going to discuss, understand it. I am taking to you. Now try this question. Very basic. This is the one cylinder is there, beta. It's the cylinder. This is the cylinder. Okay, its radius is r and its length is l. Its length is l. Its radius is r and length is l. From this side I am putting it. This is the one electric field is E1. From this side there is the one electric field is equal to beta E2. This is E1, this is E2. Now question is very simple. What is the flux entering? What is the flux entering? I am giving you again 1 minute time, try to solve it. And flux exiting. Flux exiting. So flux entering and flux exiting, that is the question. So from E1 and E2 you have to calculate total flux entering. From E1 and E2 what is the total flux exiting? That is the two questions are there. You have to try it. Okay. King, Gayatri, Chandana, you can try, you can get the answer. Okay. Please try. Try it. King. Okay, you are getting some answers. Minus pi r square E1. Good. And plus 2RL. Okay, very good. And E2. Very correct. Correct. Other person also try to get the answer, beta. Gayatri, Chandana, another person try to get the answer. Okay, I am solving this question again. You have to understand. So from E1 I am writing it. The very first time put the sign first. This is the positive, you are putting it. Now when you are writing it, due to E1 I am writing first. So when you are writing due to E1, so you will say E1 into this circle radius already R given to you. That means directly you can say area is equal to pi R square. Similarly from exiting also you can say E1 into sir pi R square into pi R square. It's a very simple thing, we can put it. Now come to due to E2. When you are taking a one cylinder, suppose I am taking one cylinder is there. This is the one cylinder. I am making a cylinder. Try to understand it. This is the one cylinder I am making it. Focus. Okay, this is one cylinder is there. You can see this is cylinder. Okay, this is circle and this is the length is given to you. So this is cylinder is there. Now you are understanding this is cylinder. This cylinder, this radius is R and this length is equal to L. So when you are putting from this side a light, so what it will appear? It will appear like this. This is the one, what beta? One rectangle. It will appear like this rectangle. This projected area would be rectangle. So this side would be 2R equal to diameter. This is 2R and this is what length L. So what is the projected area? This is 2R into L. That is equal to projected area. So I am just writing here, this projected area would be like this. It will appear like this. So this is 2R beta, it is L, it is the projected area. It is the projected area. Projected area. And what is the value of this? So directly you will say the area is equal to 2R into L. 2R into L. We can write it. And directly using this 2RL, you can write now flux. So due to E2 you are writing it. So you will say sir plus E2 into 2R into L. This is the flux entering side. Definitely negative. Exiting side is also same thing. So you will say plus E2 into 2R into L. That is the very basic thing that we can write it. This is a flux entering, flux exiting. Now tell me beta, it is clear to everyone? Chandana, very good beta. You are getting the answer. King, correct answer beta. Gayatri, E2 you have to multiply beta. 2RL correct, but you have to multiply with the E2 also. So this is a very basic thing that we are writing it, that the flux part we are discussing here. So any shape is given to you, you can solve it, you can get the answer. Now very basic, I am taking it, now you have to solve it. Please understand one more thing I am putting it. One more thing I am putting it. Now try to understand it. Any basic part I am putting, you have to understand it. Listen carefully. If I say here, if I say, you will understand very basic. This is the one sphere. It is one sphere beta. And its radius is equal to R given to you. Radius is equal to R. From this side there the one field is there. That field I am telling you that value is equal to E naught. What is the field? E naught. Now question is simple. Again the flux entering and flux exiting you have to understand it. Okay. What is the flux entering and flux exiting? You have to calculate it. Very simple question I have given to you. Please try and tell me. I am asking you what are the flux entering and flux exiting you have to calculate. You can tell the answer. You have to tell the answer. Take your time and solve this question better. Solve this question. Then we will see some more problems. My first concern is very simple beta. You have to learn the flux. If you understand the flux very clearly, you can solve Gauss law much easily. Okay. So first we are focusing more on flux part. King, good beta. Chandana, Gayatri, put your answers, beta. Again, King, very good, beta. Correct, beta, very good. Now you have to solve it, you have to write it. Again, what you will say, suppose there is one sphere. Right now I am not having any ball or sphere in this room. So, okay, no problem, you can understand it. This is the one sphere. If you put the projected area, so this would be again a circle. So what is the circle? If you see it, this circle would be look like this. This is the projected area, beta. It is a projected area like this. Again, its radius is equal to r. You can say, so this area, projected area is equal to pi r square. So you will say from here that the flux entering is equal to minus sign again, and similarly the flux exiting is equal to plus sign. That you have to put it. Very basic thing. First you have to write it. What is the field? That is equal to E naught into what is projected area? Pi r square. You can write it, and very simple, this is the answer. Similarly here also, this is E naught into the projected area is equal to pi r square. You can put it, you will get the answer. Flux entering, flux exiting. Clear, beta? Gayatri, King, Chandana. This concept is very clear to everyone, beta. Now, if you are clear, then please put your in chat box. Now we are going to solve some more problems. I am telling you very basic question. Listen carefully. Next problem. This is your XYZ. XYZ. This is a one coordinate system is there, XYZ. And this XYZ, if we see, there is a one square seat is placed here. This is the square seat is placed. This square seat is placed, beta. This length is L. It is also L. No problem. You can see this is square seat. And this square seat is placed here. Now question is that if electric field is equal to 2I cap plus 3J cap plus 4K cap, it is given to you Newton per Coulomb. 2I cap plus 3J cap plus 4K cap, it is given to you Newton per Coulomb. This is electric field. Question remains same. What is the flux entering? By the way, there is no meaning to write enter or exit because there is only one plane. So definitely the whatever is entering, the same is exiting. So I am writing only flux word. So what is the flux for this plane? And I am writing the name of this plane. This is A, B, C, D. I am writing again. This is the flux of A, B, C, D. So what is the flux of A, B, C, D? I am asking this question. What is the flux of A, B, C, D? That you have to solve it. Because there is no meaning of writing entering or exiting because it is a open surface or plane surface. It is not a closed body. If it's closed body, then only it is having a meaning of entering or exiting. Because the only one surface is there, then directly you can take it what beta flux. There is no meaning of writing entering or exiting because whatever is enter, the same is exit. Okay, because there is no thickness, it is not closed body. Using that concept, you have to write the flux. I am giving you again the 40-second time. Try it. Try to get the answer. Very simple question I have given. Try it and solve the answer. Solve it up. Very good, beta. King. Gayatri, very good. You are getting the some answer. Good. Okay, I am repeating. Very simple thing. This is the one area. Now see this area. It is placed in xy plane. What plane, beta? Xy plane. So whatever the field is passing through it would be perpendicular to it. Which field can pass? Perpendicular to it. So perpendicular means what? Only z direction or z direction. No x direction, no y direction, no field will pass through it. Only the z direction field will pass through it. So z direction field is how much? 4. So 4 into this area. What is the area? L square. So directly you will multiply, you will get, sir, 4 into L square. That's the answer. That's the flux. Clear? Very good, beta. Gayatri, King, both answer is correct. So you can see this is a very basic thing, xy plane, xyz plane, that we can solve it. Now, again I am giving you another question. Try it. That's a very good question. If you try, definitely you will get some answer. This is again I am putting it xyz plane. XYZ plane. It's the XYZ plane, and this XYZ plane, now we have to put it. It is also one square sheet, and this square sheet is making some angle with the x-axis. This angle is theta, this side. So there is the one plane is there. Suppose this is the one sheet is there. If you take it, this is sheet, and this is the xy plane with this x direction. It is making some angle theta. So this making some angle theta is given to you. This angle is theta, and again the field is there. Try to understand it. Again the field is there. What is the field? I am telling you the same field, that if E equal to 2I cap plus 3J cap plus 4K cap, that the same field I am giving you, Newton per Coulomb. Now question remains same. Calculate the flux associated with the plane, and I am writing again. This plane name is ABCD. This plane name is ABCD. Okay, this plane name is ABCD. Madhu, Vicky, beta. Okay, try to solve this question, beta. Try to solve this question. So this is the one good question I have given to you. Try it. King, your answer is half correct. There is one more part will come. Check it. Half part is correct. King, Gayatri, Chandana, Madhu, Vicky, beta. Try to solve this part. Beta, you are in a wrong room, I think. Madhu, Vicky. Okay, you are in a wrong room. So you can ignore the class. That would be better for you. Very good, beta. You can skip. Madhu, don't waste your time. You have a very precious time. Okay, and this is a useless class for you. So definitely there's no meaning of it. Don't waste your time. Life is very precious, and your time especially is very precious. So don't waste it. Okay. Now, please try to solve this question. That very simple thing is there. The king. Beta, your answer half correct. Other part is you have written that is not correct. Now I am explaining, beta. Other persons also try to see. When I am saying this is a one this plane is given to you. Now using this plane, if I ask you what is the area, so directly you will say, sir, its area is equal to L square. This area is equal to L square. Now this area is having two components. Area is having two components. Very good. This area is having two components. Correct, beta Gayatri. Your answer is correct. This area is having two components. One is along what, beta? XY plane. One is along XY plane and one is along YZ plane. One is along YZ plane. Okay. Okay. YZ plane. This is XY plane and this is YZ plane. So I am just telling you, okay, the very simple thing, you can put it here. Okay. This is a very simple thing. This is X, this is Y, this is Z. This is X, Y, Z. This is very basic thing. So for that I am just telling you, you can put it like this. You can put it like this. This would be one area projected and similarly this would be projected area. What is the area? Suppose I am saying this is A1 area. Suppose I am saying this is A2 area, beta. And this A1 area would be A into cos theta because this component is theta. So you can take component as cos theta. Similarly, if I ask you A2, so this would be sin theta component. Remember this thing, whenever any vector is there, so nearby theta component is what, beta? Cos. And away from theta we call it sin. So this nearby means xy plane component would be cos theta and this would be A sin theta. These are two components. So they are two components, A cos theta and this is A sin theta. Using this we can find now flux entering or exiting. Oh, sorry, flux only because no meaning of entering and exiting. So when you are writing the flux, now try to see. The first time writing, suppose this A1 area. So A1 area is how much, beta? You can say A cos theta. This is the field, sorry, area. And what is the field passing through it? Because this is the xy plane. So perpendicular field would be passing. What is the perpendicular field means? Z. That is the 4. So you can multiply with 4. That's the first thing. Second area is A2. This is A2 area. That is the A sin theta. You can say that is equal to, sir, A sin theta. That is the A sin theta. This is A sin theta we are putting it. Perpendicular to this is a field. Because this is YZ plane, so perpendicular field would be what, beta? X. Perpendicular field would be X means 2. You can multiply with 2, that is the answer. Now you can just put the values, you will get area. We have already calculated L square. So you can say 4L square into cos theta plus 2L square into sin theta. 4L square into cos theta and 2L square into sin theta. That's a very simple thing, beta. Madhu Vicky, there is no meaning of to ask the salary. So I am telling you, never ask to anyone. I and IU. Okay, never ask. I and IU, don't ask to anyone. What is the meaning of I? Means income, IU means age. Don't ask it. Because no one is going to reply this. And no one should also reply it because it's not good idea. Okay, now everyone has understood what is the meaning of this. Okay, you understood, beta? King, very good, beta. Other people also please reply. Gayatri, Chaitanya, it is clear to you? What is the flux? 4L square cos theta plus 2L square sin theta. That is the very basic thing. So I am just telling you this is the very basic to calculate the flux part. Now I am taking to the next point, next topic that we call is Gauss law. So when we are talking about the Gauss law, and now we will understand the what are the meaning. I am confused at components, sir, but now understood. Now clear, beta? Gayatri, please put your comment again. Now it is clear or not? Otherwise I will explain it again. Gayatri, beta, now it is clear? Gayatri beta, it is clear? Madhu beta, focus on your class. Okay, your time is very precious. You can watch some good stuff, you can read some good stuff, or you can do some productive work. So don't waste your time. It is a useless class for you. Okay, it is totally useless because I am teaching something lactic flux or something. There is no meaning of it. Okay, so focus on your work. This is a very basic thing I am putting it. Thank you, beta. Gayatri. Now come to the next point. I am taking to you the next topic, that's the Gauss law. Now please understand, this is the Gauss law. That I am writing is Gauss's law. The Gauss's law I am talking about, what is the meaning of this, please understand. He said very simple, suppose there is one any closed body is there. And this is the closed body, I am talking about very simple, no confusion, closed body. If it is any closed body is there, and in this closed body there are some charges are there, q1 minus q2 plus q3, this is a minus q4 and q5, okay, this is q5, this is a different charges are placed here. And then he said very simple, the total flux is equal to closed integral of E dot ds is equal to q enclosed divided by epsilon naught. This was the statement given by Gauss. It is a mathematical statement I am telling you, and I will say very important law. This law can be proved also using Gauss law, Coulomb's law. Coulomb's law, using Coulomb's law you can prove it. I will show you also, but right now we have to understand this mathematical part is there, two part is there, then you have to understand it. What is the meaning? Total flux, if you want to calculate, there are two ways. Either using the field, if field is given, then you can solve the flux. So till now I was doing the same job. I was calculating the flux again using this field part only, field and area. I was using it and I was calculating the flux. Now second part also to calculate the flux is, if you know the charge enclosed in this closed body, charge enclosed into the closed body. So if charge is there, then also you can calculate it. This is the second way to calculate the flux. But by the way, the flux is equal to the closed integral of E dot ds. Flux also equal to q enclosed by epsilon. That means these two terms also equal. That means this second term and this third term also equal. That means closed integral of E dot ds is also equal to the q enclosed by epsilon. That means these two are equal. What is the meaning? Meaning is very important. If you want to calculate the field, so using this q enclosed you can calculate. I am repeating again. Using this q enclosed you can calculate the field. Understood? Now this is very important law to calculate the many different places to calculate the field. We will see some application with the time. Okay, but right now I am just focusing on very basic thing. This left side field is not due to only enclosed charges. It is due to all the charges. What is the meaning? It is due to also q1, q2, q3, q4, q5 or any other field is present. Due to all the thing, it is a net field. It is a net field due to q1 also, minus q2 also, q3 also, minus q4 also, q5 also, or any other field is also existing here. Suppose any field is existing, suppose this is the E1, using this all part, this is a net field I am telling. But right hand side if you see, this is your enclosed charge only you have to consider. You have to consider only enclosed charges. Forget about anything. Just take enclosed charges, means q1 minus q2 and q3, you will get the E value, net E value. So this E is the net electric field, but in right hand side we are taking only enclosed charges, not all the charges. This is the beauty of Gauss's law. This is the beauty of Gauss's law. So this statement is clear to everyone. Beta, please reply. King, Gayatri, Chandana, please reply. Clear beta? Good. It is clear to you. Now using this concept, I am not taking this as a bulk today only. I am just focusing only flux part now. What is the meaning of flux part? So I am saying that from the field and area, we have already calculated the flux in last class and today's class. But now I want to focus on another part also, due to enclosed charge and epsilon naught. Suppose I want to write here what is the flux. So you will say, sir, here flux is equal to, very simple, this is Q1, okay, plus minus of Q2 plus due to Q3, these enclosed charges divided by epsilon naught. This is the flux. This is the flux that we can calculate. This is the very basic thing. So for this diagram, this is the flux, we can write it. It is a very basic. Now there is a one more thing you have to understand it. This flux is independent of size and shape of closed surface. Very basic thing I am telling you. Okay, very basic thing I am telling you. Now you will say, so what is the meaning of this? Please explain. Yes. Suppose there is one charge is there, beta, Q. And if I say there is one small surface, it is surface 1. One surface is this. This is surface 2, closed surface. Another surface is this. This is surface 3. Another surface is this, closed surface. This is a surface 4. Now question is very simple. Please tell what is the flux associated with surface 1, surface 2, surface 3, surface 4. So you will say, sir, flux due to surface 1. Please check. So surface 1 is there. What is the charge inside? Q. What is the total flux you want to write it? Directly you will say the Q by epsilon. Similarly, if I ask you what is the due to surface 2, if you see the surface 2, how much charge is there? Q. So again, what is the flux? Again, you will say Q by epsilon. So surface 2 also flux is Q by epsilon. You can write it. Now surface 3. Now surface 3, again you will say how much charge inside? Again the same, that is equal to Q. So what you will say? So Q by epsilon. Same for, you can write it 4. If you see the 4, what is the charge inside? Only Q. What you will say? Again that is equal to Q by epsilon. So what you understood? It depends on the size of, or it depends on the shape of the surface? Answer is no, it does not depend. So sometime in the paper they confuse you. Suppose one charge Q is placed inside the sphere and radius is R. Okay. Now the radius of a sphere becomes 2R or 4R or 10R. What is the flux? What is the flux? Same or different? Tell me, beta. If in the sphere the charge Q is placed of radius R is there, sphere radius R, and one charge is placed inside the sphere. So what is the flux? Q. Q by epsilon. But if I say this sphere radius become 2R, now what is the flux associated with this sphere? Can you tell? Gayatri, King? So it remains same. It remains same. Correct. It is very clear to you. Now, I will explain this in much detail. Please focus. I will tell you. Suppose this is the one is I am telling you the very simple. This is the sphere is there, beta. I was saying this charge is Q, and now so the same become, now this is a charge Q, and I was saying here the radius was R, and I am saying this radius is equal to 2R. So this flux is equal to Q by epsilon naught. So then in second case also, if I ask you what is the flux here, so again what you will say? Q by epsilon naught. It is not going to change it. It's the one question. Question 2 I will tell you. I am asking very simple question. Okay, suppose this is a one sphere. At the center, radius is charge is Q. At the center it is placed. Try to understand it. And radius is R. Radius is R. It is a sphere. So calculate the flux one. Second thing is, suppose it's the same sphere. Its radius is R, but this is a charge Q is placed here, just nearby the surface, just nearer to the surface. Now question is that find the flux 2. What is the flux 2? What is the flux 1? Can we solve? Can we solve, beta Gayatri? King, please tell me the answer. What is the answer, beta? Correct. Gayatri, very correct, beta. That's the answer. You can say in first case also, sir, this is Q by epsilon. And second case also, this is also equal to Q by epsilon. You can put it. Very simple thing. That's the very basic thing we can put. So it does not matter where you are placed. But listen my words carefully. If any point charge is there, don't put on the surface of this surface, closed surface. That means Gaussian surface. This surface we call it Gaussian surface. What we call it? Gaussian surface. Don't put any charge on the surface. What is the meaning? Point charge. Suppose there is any point charge is there. If I ask you, suppose this is a surface, Gaussian surface. Okay, suppose this charge is Q, and I am asking it, closed surface it is. So what is the flux here? Can you tell me? This is the first. And second case is there. This is same surface I am making it, but now this charge is placed on the surface, that is the Q. Now we have to calculate the flux. That is the second case. This is the second case. Can we solve? Yes. What you will say? In first case, this is the Q by epsilon naught. It is Q by epsilon naught. This is the answer. It's the Q by epsilon naught. In second case, what is the answer? The answer is we cannot define. Cannot define. It is not allowed. Not defined. Now, why not defined? Because you are putting on the surface. You are putting on the surface. So, putting a point charge particle, or we call discrete charge particle, putting on the Gaussian surface is not allowed. Putting on the Gaussian surface is not allowed. If it is continuous charges, we will learn in the coming days. I will teach you, but not right now. Now I am focusing on the point charges only. So what is the flux? Putting continuous charges, no problem. You can put on the surface. But if it is a charge, is either it should be inside or it should be outside, but not on the surface. It should be either inside the Gaussian surface or it should be outside, but it should not be on the surface. If it is on the surface, we cannot define. It is clear, beta? Understood, beta? King, very good. Gayatri, it is clear to everyone? Please reply, beta. Clear or not clear? There is some more region, beta. King. I will explain with the time, but right now I am not focusing on that part. Okay? Now I am telling you only. Okay, this is not defined. Now, this is very basic thing. Now come to the next point I am taking to you. Now the question comes to you, try to solve it. I will say, suppose this is the one sphere. It is a sphere, beta. For your understanding, it is a sphere. I am drawing something. Now you can see this is sphere. Drawing this line means this is telling you if this is a 3D body. And I'm saying suppose this radius is also R, don't worry about it. And at the center there the one charge Q is placed. What is charge placed? Q charge is placed. This is the one sphere, and this sphere is given to you. This is the sphere beta. It is a sphere, and the radius is R, and charge Q is placed at the center. Now, very first question comes to you. What is the flux here? Can you tell me the flux? Can you tell me the flux? What is the total flux? This is question 1. Please tell. Okay. Now, I am giving second question. The other one cylinder is there, beta. It is cylinder. And for your understanding, I am drawing this as a 2D, 3D picture. You can understand like this. At the midpoint here, this charge, there is one charge Q is placed here. Q charge is placed. Suppose here to here this length is L. I am putting it, and this length is also L. Don't worry about it. This is the one cylinder. Now again question is there. What is the flux associated with this cylinder? Second question. Third question I am asking to you. There is the one surface like this. This is a 3D surface. You can see this part. Okay. Just wait. I'll draw it again. This is the 3D picture. Now you can see. And I will show you this is 3D actually. It is a very simple part like this. Okay, like just like two cones are there. And at the center here, again one charge Q is placed. Now again question is that what is the flux associated with this? These are three basic questions I have asked you. Please, this is sphere, this is cylinder. You can write it. This is cylinder. But I cannot name it because these are two cones. You are closed it. So this is the one surface is there, closed body, and this charge is Q. Now question is that what is the flux? Please tell me in each case. Each case, what is the answer? Gayatri, King, please reply. Tell me your answer. Correct, beta, King. But answer, tell me the answer. I am interested in the value, numerical value. I am interested in the numerical value. What is the value? It will come. Tell me the answer, beta. Gayatri, King, same flux, Madhurata, correct. Tell me the value. What will the value would be there? Value would be how much? Question is that what is the value? Q by epsilon naught. Very good. So you can say this is the Q by epsilon naught. Correct. This is a Q by epsilon naught. It is also correct. This is the Q by epsilon naught. I think there is no problem. Any problem in this? It is clear to everyone? It is clear to everyone, beta? Clear na? King, Gayatri, Madhulata, clear na beta? This answers is clear to everyone. Now, if it is clear, now the second question comes to you, beta. Second question comes to you. Please focus. Suppose I am taking only above hemisphere. Only above hemisphere I am taking, beta. Okay, and I am placing charge Q. Similarly, here also I am taking only above half cylinder only. and placing charge q. This length is L. And similarly here also I am taking above cone only and placing charge q like this. This above part is over now. Try to understand. Above question is completed. Cut. Over. Now again these are three questions. 4, 5 and 6. Now question remains same. Calculate the flux associated with each body. What is the flux associated with each body? Correct beta? Madhrata? Mathala? Correct beta? Correct? You are getting the answer? Other person also beta, please tell. King? Beta, it is defined. King, it is a defined. Try to understand. It is on the surface now, but not at the boundary. Try to see. This is not at the boundary. We can enclose by putting another hemisphere. If I want to enclose it, I can put another hemisphere. It would be closed. Now there are two hemispheres are there. Try to understand. Then total flux was q by epsilon. Think carefully. If the charge is q, there are two hemispheres like this, above and below. Then total flux is q by epsilon. These are two. Symmetrically this charge is placed. So if I ask you what is the flux associated with the above, so you will say, sir, half here and half here. Total becomes this q by epsilon. So what is the half? Q by 2 epsilon. Q by 2 epsilon. This is the flux here, beta. Clear? Now similarly here also, this is the one cylinder, above lower part also one cylinder. If you enclosing it, this becomes total flux, that is the q by epsilon. So if I ask you only above part, so how much would be the answer? Again the flux is equal to q by 2 epsilon. That is the concept that you have to learn it. Similarly, in the third case also, this is a one cone, it is also one cone, you are placing a charge q here. So if it charge q is here, now again question same, what is the flux associated with the above cone? You will say, so this cone both are identical, then what is the flux? So half flux would be associated with the one cone. So what is the flux here also? You will say that is equal to q by 2 epsilon. This line is clear to everyone? Please tell, it is clear or not clear, beta? Gayatri, King, Mathala, clear to everyone? If it is clear, then we will go for other things. King, beta, clear? Very good, correct answer. Gayatri, your answer is also correct, beta. Clear, beta. Very good. Gayatri, King, Mathala. Very good. Now, so I am keeping today's class up to here. So I have just introduced the Gauss's law and we have discussed the flux part. Okay. In the tomorrow's class also we will continue with this flux and then we will go for the calculation of electric field using Gauss's law. Then we will learn the few important results and we will discuss it. Okay. Thank you, beta. Thank you so much for your time and take care. If you like the class, you can like it. You can share with your friends and classmates, your relatives. Thank you, beta. Bye bye. Enjoy your evening with a cup of tea. Okay. Bye bye.